Today we will be talking about fractions and specifically addition and subtraction of fractions. Now let me reiterate that for everything in math there are always different rules for addition and subtraction than for multiplication and division. And fractions are a clear illustration of this fact. So we're going to talk about addition and subtraction with fractions. And specifically, we're going to talk about this property of adding and subtracting fractions that makes it really, really easy to add and subtract fractions. And that is that, say you have a fraction that is a over b, right? And to that fraction, you're going to add c over d. Okay, just a little refresher before we do that. If I were to add 5 over 2 plus 7 over 2, okay, these have a common denominator of 2, and so all I do is I keep the 2 on the bottom, and I add 5 plus 7, and I get 12 over 2, which in this case simplifies to 6, right? Okay, cool. So let's erase all that stuff. And what I'm going to show you is a secret to creating a common denominator, so you don't have to go through all of that craziness of trying to figure out what the common denominator is. Basically, what I'm going to do is I'm going to take this first fraction here, and I'm going to multiply both the top and the bottom by the bottom of the second fraction. Okay? So I'm going to say a over b times d over d. And then to that, I'm going to add, I'm going to take the second one, okay, and I'm going to multiply both the top and the bottom by the bottom of the first. So it's going to be c over d times b over b. Okay? All right. So, so what happens here is, what you'll notice is, all right, so multiplication with fractions, easy peasy lemon squeezy, multiply the top times the top and the bottom times the bottom, right? So you're going to end up with this fraction that is a times d over b times d plus c times b over d times b, right? And the thing to be focusing on here is right here, bd db. See, there's this little thing in multiplication called the commutative property. And that basically says that if I take 5 and multiply it times 2, that's going to be the same as taking 2 and multiplying it by 5. Okay? So it doesn't matter what order you multiply it in. And what makes that nice for us right now is that this is going to end up being AD over BD plus CB over BD, right? I've taken these two and I've just switched them around using the commutative property of multiplication. So what does that mean? That means that all I'm going to end up doing is doing AD plus CB over BD, and I'm done. Okay? This is pretty powerful. Stay with me here. This is pretty powerful. We're going to show you a way to do that first with regular old fractions and then with rational expressions. So let's say I start with 5/8 plus 2/3. Okay? I want to know what 5/8 plus 2/3 is. Well, I'm going to take my 5/8 and I'm going to multiply the top and the bottom by 3, which works because 3 over 3 is 1, right? And I multiply anything times 1 and it's itself, so I haven't changed anything. And to that, I'm going to do 2/3 times the bottom over here, which is 8 over 8, right? Okay? So 5 times 3, remember multiplication, easy peasy lemon squeezy. 5 times 3 is 15. 8 times 3 is 24, okay? 2 times 8 is 16, and 3 times 8 is 24. Hey, look, what do we have here? We've got common denominators. So now all I have to do is add 15 plus 16, and I'll get 31 over 24, right? There you go, and you're actually done. So you see how you did that? Let's do something where you're going to actually do some simplifying too. So let's say I have 11/12 minus 1/5. So my rules for addition and subtraction are the same as each other, more or less, even though they are different from multiplication and division. So I'm going to take my 11/12 and I'm going to multiply both the top and the bottom by the bottom of this, times 5 over 5 minus 1/5 multiplied by what, guys? That's right, 12. 12 over 12. Remember, I'm just multiplying by 1 in each case, all right? 11 times 5 is 55. 12 times 5 is 60. Minus 1 times 12 is 12. And 5 times 12 is 60. So I have 55 over 60 minus 12 over 60, which equals 33 over 60. And I can reduce this. I'm looking at this. I can tell 33 divides by 3. 60, which of course is 6 times 10, also divides by 3. So I'm going to divide both the top and the bottom by 3, and I'm going to reduce this to 11 over 20. So you see how that works? No more scrambling all around trying to find the common denominator. You've got it right there. So now, let's do the big one, which is, what if I have a rational expression? 3 over x plus 2 plus x minus 3 over x. It's going to work the same way. I'm going to take this first one and multiply it by this on the top and the bottom. So it's going to be 3 over x plus 2. I'm going to go ahead and put this x plus 2 in parentheses, times x over x, okay, plus, I'm going to put my x minus 3 in parentheses too to show that the whole thing is a unit, over x times, okay, x plus 2, right, on the top and the bottom. X plus 2 on the top and x plus 2 on the bottom. Okay? So that's going to equal 3x on the top. On the bottom, what are we going to be doing? We're going to be distributing this into here. Okay, this is distributive power. So I'm going to end up with x squared plus 2x. To that, I'm going to add whatever I get when I do this, right? When I simplify that. So I've got my, let me go ahead and get my blue again. So I'm going to do my FOIL, x times x, x times 2, negative 3 times x, negative 3 times 2, and I'm going to end up with, let's see, x squared plus 2x minus 3x minus 6, so it's going to be x squared, minus 1x, which will be just minus x, minus 6, over x squared plus 2x. Whoa! Hold the phone. Look what we have here. This and this are the same. So basically I'm going to add 3x to this, and when I do that, 3x plus x squared minus x minus 6 means I'm just taking my 3x, I'm combining like terms. I'm combining the 3x and the negative x there. Okay? So what I'm going to end up with here is x squared plus 2x, because 3x minus x is 2x, minus 6 over x squared plus 2x. So we'll have more like this, but I just wanted to get this into